question is just asking you how many real there we go. So all it's asking for this one is it is asking for, it's not asking for the exact X-intercepts. It's not asking for the exact roots. It's just asking how many. So when it's just asking how many, what do we get to use? We don't have to use the whole quadratic formula. What is that called? The discriminant, which was the b squared. So here we go. Let's try this again. See if this thing's working.
Smartboard was acting up today.
B squared minus 4ac. This just allows me to determine how many. Now, let's see this question was different. Let's say they say, what are the roots? Or what are the X-intercepts? What would I then have to use? If you have to use the whole quadratic, the opposite would be plus or minus the square root of b squared minus 4ac all over 2a. You have to use this whole thing because this whole thing actually finds what they are. This part right here just allows me to determine whether I have 2, 1, or 0. And that's talking about reals. Are you with me on that? Okay. Hopefully, we're good so far. Alright, so here we go. If I was doing b squared, first off, can we label our a, b's, and c's right now? Because we might have just a hard time. We can't label a, b's, and c's. We got no shot at doing this correctly. Yeah. A is what? -3. Good. B is what? And C is? Good. Don't forget that that's not right there, is it? So b squared is going to be 2. Remember, when you plug in, what did I tell you to use yesterday? Because if you don't do this in a calculator, if you don't put the parentheses around that, you put it in the calculator, if you put this in a smart calculator, meaning one of those scientifics, it's going to pop out a -4. And you are going to get this answer wrong because you've got a -4 when it should be a +4. Remember we talked about the difference. That's the reason I did that yesterday. This is real. This is where you're going to possibly make mistakes. Do not do that in a calculator. If you have to use one, make sure you put your parentheses. If it's a scientific, meaning it has, you know how they have the windows up there? You should see parentheses -2, parentheses square root, or square. What about graphic? Same thing. That's considered also would be the same thing. It's just a more scientific. But one of those like keystone calculators, you don't have to put the parentheses around it. It doesn't have a window bar. So for this calculator right here, you would put, let's see, maybe it is scientific. Alright, 2 squared minus 4 times -3 times the -1. Be careful on this one. Got a lot of negatives over there, don't we? Okay, 2 squared is what? Minus. I'm just going to leave that minus there. Actually, we'll see what happens. Let me erase it actually. Let's just leave that. What's a -4 times a -3 going to be? 12. A +12. So I'm going to write that up there. And a 12 times a -1 is going to be a what? So does everybody see how I can write it like that right there? Yeah. And do I care really about what this value is? What do I care that it is? Positive or negative. Positive or 0. And this is negative, so I have 2 imaginary roots. A, 1 negative, sorry. B is 1. And C is another negative 1/2. 1 squared minus 4 times a half, and it's a negative, times another half. 1 squared is 1. Yes? This should be a negative 1/2 also, huh? Negative 4 times the negative 1/2 is negative 2. Negative, oh, it's positive 2, you're right. Positive 2 times the negative 1/2 is a negative 1. Everybody see how I got that? 1 minus 1 is? So what does this have? It does have a root. It has one real root, and it's also known as, why did I split that? One real root, and it is a double. It's a double root. That means that that root happens twice. How did I know that? What is my x to the power of? 2, right? So how many roots do I have to have? 2. So if it only has one real, it's because it happens twice. Remember, it has to have 2 roots. In the original equation. Alright. Final one. A is 2. B is negative 5. C is negative 6. B squared is negative 5 squared. There's where we could run into our issue. Minus 4 times 2 times the negative 6. This squared is what? Now, you could do 4 times 2. See if you can get this logic. We've got a positive number right here, right? What's a negative times a positive? It's going to be negative. But a negative times a negative is going to be a. So I'm going to end up with 25 plus something back here. Do I really care, again, what the numbers are? So what is this going to equal? Some positive number, which, what does that tell me? That it has 2 real roots. Are you following my logic on this kind of stuff? It's not that I'm trying to cheat the math, I'm trying to make you really understand the math. As soon as I realize that this number is going to be positive, that's really all I care about. I don't care about what the actual number is. Not for this example. Are we done? Alright. What can we get rid of right away? Goodbye. How do we know? Because this thing is facing down. What other thing do we say we could get rid of? Someone told me this, which is awesome. This is awesome. What is my y-intercept? It's negative. So what one can I get rid of? Why can I eliminate this one? What is this right here? That's my y-intercept. Remember, in standard form, 0, c is your y-intercept. So in this one, my y-intercept should be 0, 1. Well, that doesn't match that graph. So I can get rid of that one also. Are you with me on how I got rid of that so fast? What is the y-intercept for this one? Negative 2. Could that be that? Yeah. What is the y-intercept for this one? Negative 9 over 2. Could that still be that right there? Yes, because it's negative. Remember, they don't give us specifics on this graph over here. So I just have to go, well, it's negative. Yeah, my y-intercept is negative. So these could all match up. Now, what could be the next thing that could tell me, yes, something quick? Could I find the vertex and make sure this vertex is positive and negative so I can check the vertex? Yes, but there's something even faster. What did we just learn about? The discriminant. If I find this discriminant to be 0, what do I know it should have? 1 x-intercept. Is it touching the x-axis? So boom, I could get rid of that one. Are you following me along with that? Or I can see that it has a negative under the discriminant, and would that match up with what I have over there? Yes, Because if I have a negative under the discriminant, how many times should it touch this x-axis? And does it touch any times? So it would match up. Are you following? Sarah, are you with me? So, I'm going to do this a little quicker. I'm not going to label all the A, B's, and C's. I'm just going to go 3 squared minus 4 times the negative 2 times the negative 2. And again, I'm going to go, okay, 9, here's the negative times the negative, which is going to be a positive 8. Negative 8 times, or positive 8 times the negative 2 is going to be negative 16. When I subtract those two, what's it going to be? Negative 7. Do I really care about the value? No, I care that it's negative. So could this match up to that? Yes. Yeah, well, let's check this one. 3 squared minus 4 times the negative 1/2 times the negative 9. 9 minus 4 times the negative 4 times the negative 1/2 is a positive 2. What happens when I multiply fractions? Does everybody see that this is really 2 over 1 times negative 9 over 2? What happens to these 2's? And what am I left with? A negative 9, right? So I end up with a negative 9 right here. What's 9 minus 9? 0. Could this be this graph? No. Because the vertex would have to be where? Why do I know this would have to be the vertex? Because if it only intersects one time, the only way that can happen is if my vertex is actually on that x-axis. So this does not match up. This is the only one that would match up. How are we doing? Alright. How else could I tell whether a graph is going to have 2 x-intercepts, whether it's going to have 1 x-intercept, or whether it's going to have none? Let's think about the characteristics that I know. Does everybody see what form this is in? What form is it in? So tell me my vertex real quick. Good. It is 3, negative 4. Remember, that's going to still be on the test. So we're still going over our 2, 1, and 2, 4 stuff. This is vertex form. So my vertex is here and here. Now, does everybody see, if I graph that real quick, that's 1, 2, 3, 1, 2, 3, 4. Does everybody see my vertex is down here? Which way is this graph facing? How many x-intercepts will this have? So what do I know right away? I have 2 imaginary roots. And I didn't really do any calculations. I just used the things that I know to think through and understand what's going on. Really understanding math. What's my vertex? So same vertex. So I'm going to use the same dot if that's okay. I'll use a different color. What do I know about this graph though? What do I know is going to happen? So I'm going to have 2 real roots. Without really having to do much math, huh? Just understanding my characteristics. How are we doing? Go to C. What do I know right here? What's my vertex? 3, 0. When I graph that, if that's my vertex, how many roots is this one going to have? It can only have 1 real root because my vertex is falling where? On the x-axis. What else did I tell you to remember or think about when you know that it only has 1 real root? What is this? It's a double root. So you're going to go ahead and do number 2 for homework. I'm going to do the first one with you while I pull up my email. Alright, so if I was doing this first one, if I have concavity down and it's stretched, facing like this, how many x-intercepts am I going to have? Number and type. 2 real. And what is this going to be? 2 real. Yeah, I don't know why they're going to. Yeah. Because roots, I guess what they're trying to show you. I guess what they're trying to show you, which we've already talked about, is that roots are the same thing as our zeros. I can't understand why I say it has to do that, but yes, roots are the same thing as going to be our zeros. Maybe it's because of this one right here. For these right here, how many roots are they going to have? It's going to have 2 roots of 1. It's going to be 1 double. It's still, remember, it's still considered to have 2 roots. It just has 1 that's a double. Are you following me? So
Right here is where I'm referring to. It's only got 1 root, but it's a double, so it counts. Still has 2 roots. It just has 1 that counts twice. You following me?
For like a number of nice roots, would you put 1 double or 2 roots?
I don't care if you put 1 real root, that's a double. If you show me that kind of thing, then I understand you got the concept. That's all I'm looking for.
Okay.
I don't care how you explain that. I don't care if you put 1 real root, but it's a double. That's perfectly acceptable to me. That means that you understand the concept that this one thing is happening twice. So that's good. If I can write something in factored form, which is like right here, how many roots does this have to have? 2. Why? Because the roots are right here and right here. And remember, what is the root going to be for this one? Not -3. The root is going to be the opposite, 3. And the root here is not going to be 2, but it's going to be -2. Do you see how I picked up those roots real quick from factored form? Because factored form gives me what? My X-intercepts, which are your roots. Alright. Homework, I want you to go ahead and try to fill this in. All you're doing is you're taking these guys right here. You don't have to cut and paste or anything like that. Just write. I don't know if it asks you, but right here, all you're going to do is you're going to say, does this function, does it have real factors or does it have imaginary? I don't care which way you use. Can you use the distributed? Yes. Are there possibly other ways that you could do this? Yeah. Whichever way you decide. Remember, I told you this is in Vertex Form too yesterday? What's my vertex for this one? It would be 0, 4, because if you look, all this is being is shifted up. Remember our shifts and stuff? All it's doing is being shifted up, so I know it's up here. And which way is the same facing? So, did I do the opposite of B? Or did I do B squared minus 4AC? No. Was I able to tell that it's going to have imaginary? It's going to be on the imaginary side right away. How? Because it's not going to have any X-intercepts. Did I use that one way the B squared minus 4AC? No, I used it a different way. So that's what I meant. I don't care how you use which way. Yes.
Alright, so at the beginning of the class, we talked about focus and directrix. At least we have an idea what focus and directrix are. Technically, they're kind of like what make up a parabola. Are you with me on this? If you notice, when you had a parabola, and we're not going to talk about, we're still in functions. Everybody understands we're still in functions. And if you remember what functions are, they pass vertical line tests, right? So technically, you can have parabolas that are shaped like this, but why aren't we discussing those right now? Because they're not functions. They don't pass the vertical line test. But basically, you know all the characteristics that we've done so far? They're the same. Except you know how we had it where it says f of x, and it says x squared plus x plus 4 or whatever? if it's going to be, that's for this type of, I should have wrote that over there. That's for this type. What do you think is going to happen if it's facing this way? Instead of being x squared, guess what it's going to be? Y squared. So it's just going to be x equals y squared, blah, blah, blah. And all the same characteristics are going to follow. So it's going to be basically the same thing that I taught you. All the same things are going to hold true. Even the focus and directrix are going to kind of be the same thing. But it'll be, that's how you're going to know is it's going to be y squared. But we're not dealing with those guys yet. But do you notice that when we had this parabola, where was the focus located? It was right above the vertex. Now let's think about what that means. If I was on an x and a y, 1, 2, 3, 4. What do you notice about the x value of the vertex? What is it? What's the x? 4. What's the x of the focus? So what are you noticing that the focus and the vertex are going to have the same? They're going to have the same x. That's why it's going to look like this. This is what happens. When you have the vertex, how have we been writing the vertex? Yes, it's an x and a y, but we give them special variable for this. H, comma, k. Are you with me? With me? The focus is going to be what? What do I know right away? What did we just learn? It's going to be H. Now it's going to be, think about it. It's going to be just a little bit what? Higher than K. Or if it was facing down, it would be a little bit lower than K. So here's what we do. It's going to be K plus 1/4 A. This is nothing new. Do you know what a 1 is? Do you know what 4 is? Do you know where A is going to be found in all the different forms that we're given? Yes. Think about it. Vertex form is f of x equals A parenthesis x minus h squared plus k. Is my A located right there? Is that A that I'm talking about? Yes. If I was even in standard form, f of x equals a x squared plus b x plus c. Again, my A is located right there. And last we had factored form, and if I'm in factored form, it looked like this. And boom, I still know where my A is. That's when I'm asking for A, that's what I'm referring to right there. Are we good? We're just going to do, for simplicity, we're going to do an easy one, which would be what is my vertex? Am I reviewing your 2-1 to 2-4 stuff? Yeah. This is helping us get ready for that test. What's my vertex? Good. It's -3, -8. Opposite of what's in here, really what it is there. You with me? Now, what is my focus going to be? -3, comma, notice, he said without having to do hardly any work, -3. Why? Because the x's are going to be the same. We're going to do 8 plus 1/4 A. Let's take our time here. -8 plus 1/4, what's A? 1/4. Remember I told you I was doing a simple one just to start us off with. The reason is, what happens with the 1/4 and the 4? What does this turn to? A 1. And what's 1 over 1? So I end up with 8 plus a negative 8 plus 1. What is negative 8 plus 1? And there's that would be where my focus was located. Now the directrix is exactly, remember what we talked about. Go back to the thing about the video. So let me extend this page. Negative 8, negative 7. Alright, we said our vertex was negative 3, 1, 2, 3, negative 7, 1, or 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be somewhere right here. In our parabola, which way is it facing? So I know it's like this. Where should my focus fall? I know it should fall somewhere up here, right? Well, when I find it, it's negative 3, negative 7. Does that fall somewhere where I thought it would? Now, think about this from the video. The video said the focus is exactly the same distance from every point as the directrix is. How far did I go up to get to my focus? 1. So where's my directrix going to be? Just 1 down. And remember, my directrix is not a point, it's a what? So my directrix is going to be, I did a better job. It's going to be right there. And my directrix is a equation. Just like my axis of symmetry was. So it's not, remember when I drew this axis of symmetry, if you remember, notice not only does it go through the vertex, it also goes through the focus. Remember I told you were supposed to say x equals, and what does x equal every time I'm on this line? Negative 3. That would be my axis of symmetry. What kind of line do you think this is going to be? Not x equals, but what? Y equals, and what does y equal every time I'm on this line? Negative 9. And that would be my directrix. It would be an equation, and it would always, for facing up or facing down, it's always going to be y equals line. How are we doing on this? So really what I wrote was that the directrix is going to be y equals k, not plus 1/4 a, but what? Think about the focus and directrix. They're equal distance, right? So if this is k plus 1/4 a, what do you think this is going to be? K minus 1/4 a, and that will find you your directrix. If I ask a question on the test, it will not be a difficult one on this. This is not one of my big highlights of parabolas. Yes, it is important, but this 1/4 a will get you to what you need to get.
So, like, finding the direct or